Hello and welcome to this month's Mytech U. Today we're going to be talking about how to choose and give you a wireless comparison. With the myriad of wireless solutions that are out there on the market today, and the different size of organizations and different use cases and problems that happen with wireless, it's oftentimes our customers have a difficulty understanding how to choose which solution is right for them and why does it make sense based on what they're trying to accomplish. So today we very specifically have identified several different scenarios, hopefully that they can relate to you, as well as the means by which you can engage to understand how you can help plan those deployments. So hopefully this will definitely speak to some general audiences, but give you some specific scenarios to which you can relate. I would like to introduce, I'm Nathan Austin, I'll be the moderator today. I'd like to introduce Philip Holt, who is going to guide us through the presentation. He is our solutions architect at Mytech. And so Philip, please take it away.
Sure. Well, welcome everyone. Thanks for attending again. As Nathan mentioned, today we're going to talk about how we choose wireless solutions. And of course, it's a complicated question, and it seems one of these things that seems pretty simple. I got a box that wants to connect to something over there, and I don't want to see wires. But there are a lot of different variables that we have to consider when we're picking the right type of solution, even if the end user experience is desired to be the same. And some of those variables are listed here. We're talking about the total number of users, and to also, how often are they connecting, and are they all connecting at the same time? Is it that's a question as well. So not only the number, but also the concurrency is an issue. We have different types of devices that we're concerned about. The different types of devices may be laptops, tablets, phones, and one of the reasons that's important is because the different devices may have different types of radios, or they may only work with certain frequencies, or they may have a limited ability to send and receive signals depending on how much power they have with them. There's also a square footage of space covered. What we mean by this is that the physical area that we're trying to provide this wireless access is very critical. Obviously, if it's a smaller space versus a larger space, we need to provide more coverage over a greater area. There are some questions whether or not there's a limited amount of space we can cover with one access point. So we get into questions of how many access points and how many what type. Same goes with the materials used inside of a building, especially in indoor scenarios. Different types of construction techniques. Brick walls versus plaster lath versus standard drywall in offices all have different resistances to the wireless signals. So we need to be able to understand the environment that we're using that in, so we can scope the right equipment. And all of this is bound by, unfortunately, physics. It's not something, there are certain things that we can do with technology to make things better and to provide faster experiences and better coverage. But in the end of the day, the radio frequencies that we're using, given the limitations that we have through various regulatory agencies, can only do so much. And so as there's some value in understanding from a solution design perspective really what the physical limitations are there as well. So we've broken out a couple three different scenarios, but really three categories of scenarios. The first scenario we're going to discuss today is one about a small business using wireless for less than 30 people. We're going to talk a little bit when we get to a larger organization, what are some of the options that are available to us. And then we're going to, in section 3 here, we're going to take a little look at some specialty scenarios to present some different challenges that we can address in different ways. And then we'll talk a little bit about, once you've identified some of those use cases, perhaps some of the tools we can use to make sure we're using the right stuff. Starting with the small business wireless use case. In this scenario, we're really talking about, we have a small office, we've got 10, 15, up to maybe 30 people who are inside of a kind of standard office environment. And we're not looking to use the wireless necessarily for high-end business critical work processes, but we want people with laptops and phones to be able to access the internet, their email, some services. In a scenario like that, there's some cost-effective solutions that we have that are available, very often that integrate with the firewall itself. So most small businesses ought to be having a firewall of some sort. And if you're running a business class firewall, in the case, for example, of the SonicWall series by Dell, we have the ability to introduce wireless controllers that connect with the firewall itself to provide business class service that's also cost effective. One of the added benefits of this is that once we have the rules and systems defined inside of the firewall, adding additional access points for additional coverage can be pretty straightforward. And this scenario is generally very well suited for an environment, again, that's small, both with regards to the number of people that we're covering, but also is a standard office construction with a reasonably small footprint that we can cover with one or two access points. Nathan, is there anything you wanted to add to that? This scenario, I know we've worked with these solutions as well, and I can go into some more detail if you'd like.
Yeah, thank you. I think, Philip, the piece that I like to relay here is that most businesses have evolved to where the consumer-grade devices that you might buy down at Best Buy or something like that are typically devices that aren't really meeting your needs. Now, they're either not meeting the needs from just the sophistication of the device needed to provide a business class service. It could be limitations on the security that device can deliver. Plus, where we've seen a lot of problems with that is once if you needed to add a second one of those devices, well, they don't talk to each other. So your user experience actually is poor, because if you end up having to walk from one area of the office to the other and you connect to one of the other devices, you're actually disconnecting and reconnecting, and there's some manual intervention that's required from your staff, which creates a more complex environment and less of a quality experience. So part of where to enable a better experience, but yet keep the costs under control, this is where for our smaller environments, especially if it's one site in particular, or maybe it could be multiple sites, but yet a small user base at each site, less than 15 or 30 people, as we're noting here. The fact that you don't have to buy a separate controller to manage, one or two access points, as Philip mentioned, it's built into the firewall. So it actually reduces the complexity of your environment from a support perspective, and actually creates a better user experience. So it controls your costs. It simplifies your overall network infrastructure environment and configuration, and it provides a better user experience for your staff. So this is a couple different ways that we see very commonly being deployed in those smaller environments, because it's, like I said, it gives you the quality covered like a business class service, but it keeps the cost under control.
Great, thanks for adding that. Sometimes, me, I get to the technical side, and I really appreciate when you're able to provide the business real-world experience. Thank you for that. Next, we're going to talk about a slightly larger scenario where we may have may have more people or more area or more sites. And so in that scenario, we're looking at differentiating and really creating an entirely discrete system of wireless access. So in the previous scenario where we were looking for simplified management by integrating with existing appliance like the firewall, in larger organizations and or covering more people or more places or more surface area and square footage, we need to move to a more granularly controllable system. And all of these involve for the most part, having centralized controllers. Some of those controllers can be web-based, as in the case of some of the Xeris products, or some of them are physical-based, where you actually have a physical piece of equipment that lives on site, such as in the Cisco series. And there are other manufacturers that have different use cases as well. But the larger types of the equipment that we use in the larger use case here allow us to have more selection in terms of the different endpoint components. So in the previous scenario, we're really limited to a single type of access point that's going to work with that single type of firewall controller. As we move up into the higher grade of equipment with the centralized controllers, we may be able to place different types of wireless access points with more or less antennas that are going to be able to more specifically map to the exact use cases that we need to provide. In these scenarios also, the equipment is really designed from the ground up to provide wireless solutions, and oftentimes works higher up in the OSI layer to allow perhaps better filtering or preferential treatment of different types of services. So for those scenarios where we may have both voice and internet browsing and business critical applications running over the wireless networks, we can differentiate between those networks as well. Point of case here, we're looking at some images here of both the Cisco series and of the Xeris series, and they accomplished some of the same goals in different ways. The Xeris solution integrates multiple access points into a single physical box, whereas the Cisco generally uses individual access points that are discretely configured and set up. Nathan, do you have any comments here before I move on to some of our specialized scenarios?
Yeah, I think that where we've experienced from, like I said, a business case is that customers that started at the less than 30 people and started adding access points to that configuration where they might be using the firewall as the controller, they started running into potential performance problems, or they're not able to support the myriad of devices between laptops and desktops, not desktops but laptops, tablets and phones, and they needed some more business critical reliable sources. So they've moved in this direction. There's probably a little bit of an overlap between maybe being able to use the foundation of the first scenario that we described, but as you get into this space, which is where we typically see these solutions implemented, where you're actually not integrating the access points with the firewall, as Philip mentioned, and you're using a discrete controller, as what is shown here in the Cisco. But one of the downsides of the Cisco solution in particular, as it relates to multi-site, is that you may often have to have a controller on a per-site basis potentially, and so that could start increasing some cost if your organization is structured in a multi-site environment. And it could add some complexity to the support of that environment. Whereas Xeris has not only a local controller option like Cisco, but they also have a cloud-based or a hosted controller, so that you can actually log into a single console that will manage all access points across your organization across multiple sites. So that's also where, when you start getting into more mid-size and larger deployments, you'll start seeing the need for you'll have managers or leaders or different people that will travel from site to site, and you don't want to have to them reconfigure their wireless every time they go to a different site. You want it to automatically connect, you want it to be secure, and you want them to give them the right access to the right resources when they do. So this is where having a centralized controller or a hosted controller to be able to manage that can provide, again, the better user experience, not only because you're putting higher quality wireless equipment in place, but the way in which it's configured is also conducive to the nature of having a multi-site organization or a large site organization when you're walking between different departments or going between different sites. So having the controller piece and understanding the dynamics there is also a good, just a point of evaluation as you're trying to figure out which wireless solution makes most sense for you. So thanks, Philip.
Great, thanks for that. So kind of in summary, we have more flexibility and more granularity in our control, but that comes at some expense both of manageability and cost, and so we need to balance those things with regards to the needs.
And Philip, there's a question that came in online here too. It said, what equipment are you showing in the slide for access points on the Cisco device? So I think, I know we might have mentioned, but I don't know if we're trying to get more specific, but just to kind of maybe touch base on the Xeris real quick and the Cisco as well.
Sure. So the equipment we're looking at is this unit here is the text is kind of small, but we're looking at here is a standard Cisco wireless controller, which is a piece of equipment that lives generally with your switches in the back office. And on top, sitting on top of it is an example of one of the types of Cisco wireless access points that you can install. This one is of the AeroNet series. There are a variety of AeroNet series. There's 1100s, 1700s, 2700s. So again, again, you have the option of deploying different types of access points with a given wireless controller, and those different access points may have different capabilities between multiple frequencies, multiple radios, the ability to provide external antennas for discrete use cases. But the general construct is that the wireless access points themselves really kind of operate at a low level of collecting and sending and receiving data, but all of the traffic is brought back, in a way of speaking, to the wireless controller, which then presents that information to the network as a whole. So the wireless controller is really kind of a gateway into your corporate network, and the access points that are shown on top, like this AeroNet, are the locations to connect from, but the actual data traffic is essentially all processed and presented by the wireless controller. Compare that to the image we have over here, which is a Xeris device, which is part of their XR series. The XR series, Xeris actually places a wireless controller inside of this round house. And in this picture, what we see is that the yellow area here indicates kind of where there is a centralized controller, and the radios themselves are placed inside the same physical unit, but they are acting as, in this case, 8 separate different radio antennas, which could be tuned to different frequencies or different channels in order to provide proper coverage. And then so in the scenario of the Xeris solution of this XR series, the entry point into the network comes from this physical endpoint device itself.
The only thing I'd add to that, Philip, is that one of the things that Xeris does kind of uniquely is that the intelligence that's built into the array allows you to have a choice between filtering and control and throttling and restrictions applied at the array level, as well as having the multiple arrays connect to a centralized management point. So that's actually, again, one of the unique components of Xeris. Relative, like you said, it doesn't have to route all the traffic back to the controller like Cisco does, or like other technologies that route it back to a controller, because you can have it in both places, or you can choose where the filtering or the intelligence is applied to the wireless solution.
That's
my understanding.
That's a great point, and it actually works well into discussing kind of our first special wireless environment that we're going to discuss next. In addition to kind of the small, medium, and large application sizes, there are specialized cases where we may need to consider or look at different types of wireless equipment and scenarios. One of them, one that isn't that common but is a real challenge, is dealing with high-density environments. So what do we mean when we talk about high-density environments? We're talking about a high-density environment. We mean a lot of devices connecting inside of a small physical location or a small footprint. So very often when we're looking at wireless deployments, as we were in the first two, we're looking at what we call coverage play, is that there's a finite number of rooms and space that we have to cover, and that's the real concern, is making sure there's enough wireless access points to cover all of the physical area that needs to provide service. There are different use cases, however, where we may have a very large number of users inside of a small space. An example of that might be a classroom, or a conference, or a theater. We've done some work with churches as well, where you have the physical distance from the access point to the user is generally not a concern. But since the access points themselves, because of some of those limitations of physics, can really only handle maybe upwards of 20 users per access point, we have a different problem, which is how can I connect 200 people that are all in the same room to the same wireless network? So that's a high-density environment, and Cisco has a unique proposition to doing that, and we see that here, which is that they put multiple radios inside of a physical device. And that allows us to have more end users and devices connecting inside of a smaller space, whereas with a traditional single radio array, you may have a finite number of people that can connect to that access point before it overloads and the service provides all the users to grades.
One of the things, Philip, that I always like to relate this, in fact, when I talk to people, I usually try and ask a question. Have you ever been to a sporting event, or ever been to a hotel, or ever been, anywhere where there's a lot of people in a small space, and where you look at your phone and it says you've got signal, right? It says, like, I've got 4 bars or whatever, right? It looks like I've got all the wireless signal I need, but yet you can't even send a text message, or you can't even get an email through, or you can't even make a phone call, depending on the wireless you're talking about. So this is the kind of scenarios we're talking about, right? Which is where you've got a lot of people, a lot of devices. Each person might have up to 3 devices, by the way, right? So, and it's really understanding that each one of those radios in that, if you look at the picture on the screen there, when you look at the arrays where it says 8 modular, 12, or 16 modular, each one of those radios can only handle, as Philip mentioned, 20-ish connections, right? So if you're trying to get a lot of people in a small space, you're going to run into physical limits, and this is where Xeris can handle and help. So each one of those radios, you put more radios in a small space, and they're intelligent enough, like we talked about the intelligence on the last slide, they're intelligent enough to be aware of each other, and it can actually support more people in a small amount of space with less conflict. So that was I always try and make sure that to put it in the minds of, where have you ever been in these environments? Because almost everyone has been in an environment at some point in their life where looks like they've got wireless signal and they don't, and this is the exact problem we're talking about.
That's a great point. The difference between service signal strength and service congestion. So one of the analogies I often use is that if you have a lot of people talking in the same room, no one can hear each other. And so that uses up it's not that you can't hear one another, it's you can't understand what's being said, is because there's too many people talking at the same time. So the ability to have multiple radios inside of that smaller density space helps alleviate that. We, in fact, worked originally 2 years ago with an organization that called us up and was having all sorts of wireless issues at a convention they were running, and we were able to, by asking the right questions, identify that the problems that they were having were a density-based issue and not a coverage-based issue. And we were able to walk in and provide a Xeris solution that allowed us to use a total of actually two of these high-density arrays and provide coverage to 400 simultaneous users inside of one room. So kind of an example with using the right technological solution to the right business case, we can provide a solution for folks.
Well, one of the other things, Philip, that I want to touch base on, because there was a question that came in from the audience, but I like to, so it didn't make me think of it until the question came in, so thank you for that. But the graph here, if you think about how do you help control costs with the wireless deployment, and this is one of the scenarios where the way Xeris handles it, which is one of the reasons why we like this technology, as Philip was alluding in the conference example, is that the traditional legacy access points where there's 2 radios per access point, which means that there's a limit of about 40 devices per access point, you might have to buy, what's the number on there, 6, 7, 8, 9, 10, 11. You might have to buy 12 access points to get the coverage you need and the density that you need. There's other problems I won't get into, but just instead of buying 12 devices, you might only have to buy 3 with Xeris. So your cabling costs go down, your overall costs typically are less than if you're just trying to continually add access points. That's not always the scenario that applies to you. Again, these are unique, special applications why we're talking about this. But from a cost control perspective, this is one of the analysis we help our customers with so that they make sure they're not overspending or underspending, but also meets their requirements. So I always like again, the question that came in online made me think of pointing that out. So sorry for interjecting there, Philip.
Oh, no, appreciate it. Thank you. We're going to talk next about another specialized wireless scenario. In this case, we're going to be talking about outdoor use cases. And outdoor use cases are some of the challenges that differentiate the outdoor cases that we have. We have physical issues we need to deal with. All of a sudden, we have things like rain and sunshine and lightning strikes, as well as mounting capabilities to buildings and infrastructure. As well as we also have the issues of cabling may no longer be as convenient to drop, and where does power come from? And also the scales at which we're dealing with are generally much larger, especially when we talk about coverage play. It's pretty unusual to find a business that has 80,000 square feet that needs to be covered by one array, whereas in an outdoor environment that is a rather small, and hundreds of thousands of square feet may need to be covered, or in the cases of cities, multiple square miles. So there's different technologies that need to be used, and different types of connectivity that need to be used in order to deploy those solutions. So I have some images here of some different types of equipment, but I wanted to talk also about one of the major things that comes into play when we're talking about outdoor deployments is, in addition to the making sure that the equipment is environmentally protected from all of the weather-related items, antenna selection becomes very important. So what you often find is that the types of wireless access points that you would use inside have their antennas built into the physical casing of the unit, whereas when we're working in outdoor environments, we may need to place the equipment in a different place than we have the antennas. And so understanding the coverage that's needed and the frequencies that are being used and the appropriate types of antennas can be very critical. In addition to working in outdoors for a coverage play, there's oftentimes a connectivity play. There's another specialized use case where we may be able to use our standard Wi-Fi to provide connectivity between two buildings that don't have cables between them. So it's not uncommon in a campus environment, if I have multiple buildings and I don't have access to facilities like fiber or copper running between the buildings, I can actually use wireless to create bridges and to connect those networks. Again, the base technology of Wi-Fi is oftentimes employed to do that, but the type of equipment that's used to provide that same Wi-Fi service has pros and cons, and different types of antenna selection and power requirements may be in their consideration as well. So that's another example here where understanding the environment, the use case is critical.
Philip, can you talk, one of the things that quite frankly, I'm very unfamiliar with, other than one scenario of site-to-site or line of sight, what are some of the typical problems that you run into with an outdoor deployment? I mean, from an interference or from just not being able to deliver a good experience from a wireless perspective. Can you maybe just share a couple of those off the top of your head, what that might be impactful that we need to consider if we're doing an outdoor deployment versus an indoor deployment?
Sure. So one of the major issues when it comes down, oftentimes comes down to signal strength. So we're looking at a scenario where we have a antenna that's at the access point. But of course, in every wireless scenario, there's actually two antennas. The device itself has, the device that's connecting, be it the laptop or the handheld or the phone, also has an antenna in it. And in indoor environments, it's not uncommon. It's pretty normal to expect that if both the devices have antennas and they're located, say, 100 feet apart, we're really concerned about both the access point has to be able to hear the device, and the device has to be able to hear the access point. And when we're working indoors in small confined environments, we presume that that volume or signal strength is equal on both sides. That being, the example of that is that if the device can hear, say, 3 out of 5 bars at the access point level, and the device we therefore presume can hear 3 out of 5 bars, so that we can be more or less assured that if the access point can hear the device, then the device can hear the access point. When we move to an outdoor scenario, because of the large open spaces and, again, some of those physics of wireless propagation, we can no longer make that base assumption that the signal strength at the sending unit and the signal strength at the receiving unit are the same. So there are some special techniques and mathematical tricks that can be used, but we have to be able to accommodate and overcome the scenario where the device that's in your hand may be sensitive enough to hear the access point that's hanging on the side of the building, but the device itself cannot transmit a signal that's strong enough that the access point on the side of the building can hear the device, in which case wireless traffic will not flow, but it may appear from the handheld device that you're holding that you have 5 bars. So that's another example of where we can have a apparent issue where we have 5 bars on our device, but we're not connecting to the network. And you alluded to that. Another similar appearing situation in the high-density environments. However, in this case, the cause is entirely different and has to do with the differential between the send and receive strengths of both sides. So that is a good example of one of the unique challenges that we have on outdoor configuration.
Yeah, you know, I also remember, just kind of anecdotally in a weird way, a company that had buildings, as you mentioned, Philip, 2 buildings that weren't connected by a wire, and wireless. If they have line of sight, they can actually, if you have a lot of times the ways, if you have multiple sites in multiple areas that are far enough apart where you're connecting them over an internet connection, well, that's fine, but that internet connection is not as fast as what you can get typically with a wireless connection. So if you have the benefit of your buildings being within visual sight of each other, you can oftentimes put a wireless solution in place that can give you faster connectivity between those sites. The negative is, and I think of 2 scenarios that I remember happening, is that, or that I've heard of customers over the years have happened, where if that is across like a street, for example, if a big semi-truck happens to be stopped at the stoplight that's directly in the line of sight of your wireless signal, it might interfere with your connectivity. So that's something. So that could be an intermittent problem if your sight line of sight isn't high enough. Another scenario so it's kind of funny that could happen, but it's something to make sure to be aware of is, you know, what might get in the way. Another scenario that I remember hearing about from a customer was that they put line of sight in the fall or winter months, but the problem is then comes springtime and summer when the trees' leaves filled in that block the wireless signal. So there can be some problems there too. So you know, outdoor deployments have definitely different type of obstacles that we may encounter relative to, you know, setting up a quality experience and a quality solution for you. So again, just anecdotal.
Yeah, Nathan, I think you bring up a good point of the scenario that we've discussed with being able to manage devices really comes into play in the outdoor scenario in a slightly different way, and that we need to be able to monitor over time the quality of the connections. So certainly in a point-to-point scenario, just because we set it up and it was working today doesn't mean it's not going to be working 5 minutes from now, 2 days from now, or a month from now. So having a managed and monitored solution is pretty critical in that standpoint. In these scenarios, we'll oftentimes work with the other equipment for failover, VPNs, tunnels, or different types of routings to ensure that we can use wireless point-to-point connections where that's appropriate, but that we're able to identify when that connection stops working and have alternate arrangements programmed to the network in case that happens. Another point I just wanted to drop in there is Nathan was using the words line of sight, and for clarification, line of sight when used with regards to radio frequencies is not necessarily the same as when we talk of line of sight with your eyeballs. And I just bring that up because in another case where we'll get to a little bit later, where surveying is very important. Just because you can visually see something doesn't necessarily mean that the radio line of sight is acceptable, and also the other way around, and that just because you can't see something with your eyes doesn't mean that there isn't a radio wave path to get there. So again, that comes down to the selection of antennas and understanding what the environment is. We're going to move on to another and perhaps the most challenging wireless environment, and that has to do with high interference environments. And I have some slides a little bit later on where we'll talk about, I can show you visually kind of perhaps what some of that interference types looks like. But some examples of what we mean is, unfortunately, radio waves are a shared space, and there's open licenses provided by the FCC, and they give us a finite number of radio channels and a finite amount of radio space that we can operate in. In this country, those tend to be for the purposes that we need in the 2.4 gigahertz range and in the 5 gigahertz range. And within each of those radio frequency allotments, there's a finite number of channels. In the case of the 2.4 gigahertz space, we have essentially, although they're numbered up to 11, we functionally only have 3 channels we can work with, whereas in the 5 gigahertz space, we have upwards of 30 channels we can work with. So it is more and more with the deployment of wireless, which is an amazing technology. We find, fortunately, that everybody's all using it, and although they may have their own individual access points, they're all sharing the same connectivity medium, which is this radio frequency space. And the classic example would be if you go into an apartment building or a dorm and you open up your wireless device and you see that there's 300 different wireless networks. And the sheer number of people using that, although each one of the individual connections can be perceived from the access point to the device as being unique, they all are essentially sharing the same wire, in quotes, and that there's a finite amount of bandwidth that all of those people can share. It's similar to the high density environment issues that we discussed earlier, which is why we'll see that Xeris also has some great solutions for addressing the high interference environment problem, but it is a different challenge of the physics in that we don't have control over all of the radio waves. So we have to be able to identify and switch channels and perform some clever tricks as best we can in order to ensure the best connection for the devices that we want to connect to our wireless network, even though we're sharing the same space as others. And unfortunately, there are scenarios where this simply cannot be done, and that's where we come back to that limitation of physics. So in locations where we have dormitories or office parks where you may have many, many people trying to provide wireless access over the same physical space, we have a couple different tricks up our sleeves. One of them is to try and identify which channels may be the least used and keep our radio networks on those. And the other tricks we have is to try and move off of some of the more congested frequencies, say in the 2.4 range, and move on to like the 5 gigahertz range, which is generally less noisy, and we may be able to provide a better service. The last mechanism that we can deploy, which is, again, the Xeris solution, because it has those multiple antennas and radios that it allows us to do, is instead of trying to make the one very large signal to cover everything, we can make many, many small signals, which sometimes can provide a more localized, smaller coverage, but better experience for those people who are in those noisy environments.
Now, Phil, I think the best segue to articulate on some of those other components with regard to how do we know when there's interference or problems or nuances we have to deal with is really by how do we help plan. So I know that that's, I want to ask more questions here, but I think the next slides are actually going to help answer the questions. So I'll hold until the next section here.
Sure. Sounds great. So we'll talk over this a little bit, and then we can come, if we need to, we can come back to this. So we've talked a lot a bit about different scenarios, some specialized, some general use case, and the question is how do we decide the right solution? Someone who's familiar with wireless, in the case of the small business environment, there's not a lot of planning that's needed if we have the basic question of it's 15 users, it's not business critical per se, and it's standard office construction. We don't need to know much more than the square footage, and we drop some access points in, and we can be more or less comfortable that we'll have the right solution. As these solutions become more complex and we move into the specialized or the larger environments, we need to have a better idea of what to expect before we deploy. And we do that through a couple different mechanisms. One is providing surveys, and surveys can be of different types. We have predictive surveys, which rely heavily on math to calculate a potential answer, or site servers where we actually go out with antennas. And I'll talk about that in a little bit. The other important portion is to gather the use case and the understanding of what the current use requirements are and what the future use requirements are. And collecting that information through a series of questions on a questionnaire makes sure that the folks who are architecting and engineering the solution really understand what the expectation is Mytech has some pretty good examples of wireless questionnaires we've used, and I'm sure Nathan will invite you to ask us for a sample of that. We'd certainly be happy to share that and talk you through some of the questionnaires we have available. We're going to move on here and just cover a couple different surveying techniques. I have a slide here that represents kind of 3 different types of surveys that we use frequently. The first that I'll point out, as we discussed, is an RF analysis. And so an RF analysis is really a radio frequency analysis, and it's designed to identify what is the background noise before we deploy any wireless. So previously we talked about the high interference type of scenario, and what I have here is an image that comes from a radio frequency analysis tool. And what's slightly unique about this sort of analysis that you may not have seen before is that it is agnostic to the type of device or the type of connection that's occurring in the radio frequency range that we're concerned with. We often talk about Wi-Fi as being the primary user of radio waves in that 2.4 gigahertz. But because it's a unlicensed space, we're also competing with things like microwaves, cordless phones, the other Wi-Fi signals, but also any Bluetooth headsets, a lot of sometimes some medical-based equipment, tracking, monitoring, MRIs, anything that produces a lot of electronic interference can limit the availability or the quality of the airspace in which we're going to be presenting our wireless network. So really, in a more complex or large environment, the very first thing we need to do is we need to get a base level of what does all that other noise look like. And this is a sample of an image that kind of shows the 2.4 gigahertz channels across the bottom and indicates by its color map. And someone with the proper training can read a map like this and understand what the environment is looking like. So point of attention, the RF analysis is really done at a point in time and a point in space. And that we use as the basis for before we even start creating a solution. The next method we use is a predictive survey. And predictive surveys are defined by this picture here, where we get a kind of a PDF floor map of what a building looks like. We artificially place in known obstacles like walls, doors, windows inside of the space. And we can, using computer simulation, introduce the planned locations of various access points, and then the proper tools and software can use some mathematics to identify what is the potential coverage, both in distance and with regards to the obstacles that we know to be in place. And then the final type of survey that we use, which is sometimes used before but very often after the deployment of a wireless network, is to perform what's called an active survey. An active survey is depicted here by a guy who's walking around with a laptop and an antenna, and he would literally walk through the space with the wireless solution deployed and measure what's actually there. So those are some examples of some surveying techniques that we use in the field in order to ensure that the solution and the hardware that we're deploying both meets the business needs and that the actual solution is affecting the outcome that we had planned.
Yeah, thanks, Philip. I think that the combination, part of this was to describe is that, wireless is not as simple as oftentimes, when you have something at home and, gosh, Comcast has their wireless router and it works great when you only have 1 or 2 devices connected to it. But when you run into real-world examples of interference or a small deployment, but yet you want to keep it cost-effective versus maybe a little larger or a high-density environment or outdoor connections, we have to be aware of these. And the RF analysis in particular on this slide, one thing I love about this particular slide is that that's a piece that it affects your experience, but it's the piece that's very often overlooked. They don't, unless you're experiencing problems with wireless, and I remember us one time experiencing a manufacturing facility that had a welding device that was kicking off a lot of electrical interference, as Philip mentioned, and that was causing a problem with network connectivity. The wireless coverage was fine. It wasn't a coverage issue. It wasn't a density issue. It was an interference issue. So it's It's a very complex world, and there's a lot of solutions out there, but there are definitely ways to understand. As long as we understand the use case and really understand the number of people and the number and type of devices, the physical geography, what interference exists, there can be a solution put together to meet all those requirements. But it's important that we have good communication and connectivity, unlike a wireless questionnaire, for example, to make sure that we can help, or that you, with any other provider, can help define the solution that's appropriate, not only from a budget perspective, but to meet the coverage requirements. So thanks a lot, everyone, for paying attention and joining us today, and thanks for the questions that got sent in online. Please contact us if there's anything. This is also recorded and will be available on our website within 24 hours, and you'll get a follow-up email that'll have that link as well. So, but by all means, if there's anything we can do to help, please reach out. So, Philip, any final words? But I want to say thank you to you as well. Any final thoughts?
Thank you for attending, and thanks for having me. I look forward to talking and helping folks out next month.
Thanks a lot, everyone.
Bye.
Absolutely. All right, bye.